Hey guys, so let's go start talking about uniformly accelerated motion and Big Five. Simplest type of motion to do and calculate is when acceleration is constant and possibly equal to zero, though true uniform acceleration is rarely achieved. In the real world, make approximately constant acceleration. Notice that if acceleration is constant, then average acceleration is also constant. Okay. In this case, there's only two possible directions for motion. One is positive, and the other direction is negative. If we say it only in a straight line, displacement, velocity, and acceleration are all vectors, which mean they include both magnitude and direction. With a straight line motion, direction can be simply adding a plus or minus to the magnitude. Therefore, although we often abandon the use of bold letters and denote vector quantities of displacement and acceleration, the fact that these quantities include direction will still be indicated by a positive and negative sign. Okay, let's do this. So we know this, V initial, and V final, no subscript. We've talked about this, T initial 0, T. So we have 5 different equations. So we know this is equal to x times x initial, which is equal to velocity times time. We know that v is equal to v initial plus acceleration times time. That makes sense. That should make sense to you. We also know that change of x is equal to x naught plus v naught times t plus 1/2 acceleration times time. I actually don't know what the difference between these two is, but I noticed that the v is not final. Is now final instead of initial, so I guess you could do that. But yeah, you never use this equation. At least I don't remember. Maybe there was a different form. But also know v squared is equal to v initial squared plus 2a times x minus x naught. These are in different forms that I've seen. So I'm going to go look at these real quick later, and I'll help you. Okay. Usually, we write it as square root of v squared, v initial squared plus 2a change of x. That's how I write it. That makes more sense to me. But yeah. We use change of x rather than change of s for displacement. Because acceleration constant, average velocity is this. Does that make sense? We can derive that real quick. Because this is equal to 0. V bar is equal to that. Well, sure, if you say so. I don't really know. If it average, that's if it's 0 though. I actually don't know. This is pretty good. This is pretty good. I guess, bro. I guess. Okay, each of the big five equations is missing one of the kinematic qualities. So which you just see which one's missing. Big 5, 1, and 2 are simply the definition. And the other big 5 can use this. And a bit of algebra, okay? An object with initial velocity of 4 meters moves along a straight line. Constant acceleration is velocity later. How far did it travel during this time? V initial equals 4 meters per second. V final equals 14 meters per second. X initial equals 0, X final equals blank. So we can find change of X using X initial, X final minus X initial. Okay, so we know that X final equals to when the velocity is constant, the average velocity, t equals 3 seconds. Okay, so we can see our equations. We have these three. We're using X, so we can use this big third equation over here. They're not given A. Since we're not given A, we can use this equation over here and substitute some stuff out. This seems a little hard. I think we could literally just find the average and this constant multiplied by time. 9 times t 27 is what I would say. I guess. Put meters at the end. Think about it this way, Devianch, okay? Does that make sense?